Hello, Assalamualaikum to Dr. Aizuddin bin Supi and our fellow friends. We are from Group 4, would like to present about experiment 3, which is the application of first and the second law of thermodynamics. This group is consists of 5 members, including me, ALAZIM bin NOORDIN. Then we have FIZRI HAZEEM, NASREEN AINA, DIYANAH RAHMAN, and AMIRA ZAMROS. So we go through the first part, which is the objective. The objective of the experiment is to apply first and the second law of thermodynamics in various process and learn how this law works in the medium.
I am AMIRA and I will proceed with the theory of this experiment, which is on the first and second law of thermodynamics. The first law of thermodynamics states that energy is always conserved as it cannot be destroyed nor created and used as a basis for the calculation of heat transfer. It is also used in studying the relationship among the various forms of energy and energy interactions such as energy input and output, or also called energy balance. As for the second law of thermodynamics, as in Clausius' statement, state that the heat can be transferred from the hot reservoir to the cold reservoir easily without doing work. That explains why work input is needless for the heat flows from hot body to cold body.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is FIZRI ISMAIL, and today I'll be explaining about the apparatus and methodology of experiment 4, which is the application of first law and second law of thermodynamics. Okay, we move on to the apparatus section. In total, we are given 6 apparatus, which are thermometer, balance, kettle, stopwatch, big and a small container. Okay, we are using the thermometer to record the temperature of both cold water and hot water, while the balance is used to weigh both the container and the water, while the kettle is used to warm the water until certain temperature, and lastly the stopwatch is used to record the time. We're moving on to the methodology. Okay, first and foremost, heat the water by using the electrical kettle until a certain temperature, which in this case until 80 degrees Celsius, because we are given the data from the table. Okay, for the second step, while waiting for the water to be warm, the small beaker is weighed. Next, the hot water, which is around 80 Celsius, is filled in the smaller container and the mass is weighed. Number 4, with caution, carefully place the beaker filled with hot water into the larger container. As you can see in this picture, the lab assistant did use a thick glove in order to protect himself from the hot water in case he is injured from the hot water. Okay, number 5. Cold water is poured into the big container and ensure that none of the cold water enter the small beaker. This is to be done in order to get the exact or more accurate temperature during the temperature recording. Okay, the 6th step. The water must be filled until it has the same level as the hot water. The weight of cold water is recorded next. Okay, number 7. Place 2 thermometers, one in the hot water while the other one in the cold water. And lastly, the temperature of both water are recorded every 1 minute interval until they have the same temperature, which in this case, it reaches equilibrium.
Assalamualaikum warahmatullahi wabarakatuh. My name is NASREEN and I'll be explaining about data and calculation part. So here is the data given by our lecturer. From this data, we have calculated the energy changes for hot and cold water by using formula mass of water M multiplied by Cp heat of capacity of water times with the changes of temperature. These are the graph plotted for temperature of water in degrees Celsius versus time in minute for both hot and cold water. From both graphs, we have determined the equation of curve by using curve fitting method, which is y equal to 59.14 to the e to the power of negative 0.02x and y equal to 0.0397x plus 36. The energy changes for hot is negative 34.82 kilojoule, while the cold is 27.98 kilojoule. Therefore, we have calculated the total energy changes for both and hot water, which is negative 62.79 kilojoule. That's all for me. I'll pass to the next presenter.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is NOORDIN binti RAHMAN, and I'll be explaining for the discussion of this experiment. From the first graph shows that the temperature of hot water is inversely proportional to time. The temperature of hot water is decreasing while the time increase, where it shows how the temperature changes as a substance is cooled down. The temperature then reaches its equilibrium state when it is at the room temperature. As for the second graph, the temperature at cold water is proportional to time. The temperature of cold water increases through time, and it is also reaches its equilibrium point at the room temperature. From the calculation to achieve change in energy, the energy change for hot water obtained is less than the energy change for cold water. It is because the energy for hot water leaves the system, while for cold water, energy change enter the system. This observation completely relates to the second law of thermodynamics, where heat transfer from lower temperature to higher temperature, and the other way around, until it finally reaches its equilibrium state.
So we go through the last part, which is the conclusion. So the objective of this experiment is achieved, which is to apply first and second law thermodynamics into the various process. Then we include the few statement, which is the energy change between hot and cold water in the experiment achieved by influence of the first law of the thermodynamics. Then the second law of thermodynamics proven when the transfer of heat from hot water to cold water by the calculation in the result part. That's all. Thank you.